Welcome to Inside Valentine, a new series where I talk about Valentine, my free open source compressor, and the development process behind it. Today, I'm going to show you how I implemented sidechain compression in Valentine. We'll end up with something like this. Big thanks, by the way, to Tyreek Elliott, who made all the samples that I'm using. Besides this, I think this is a stock Ableton sample, but this pad and the drum hits are from his sets. And I like using them. So yeah, thanks, Tyreek. Doing this project taught me something new about the Juice framework and led me to do some thinking about how Valentine's compressor is implemented. But first, some housekeeping. You might notice something missing from this part of the screen. I'm not there anymore. And I'm not there mainly because I want to make this practice sustainable. And having to think about how I look on camera and having my space really nicely arranged and having the lighting right now is kind of a bit much for me. And actually not having not having video on myself is going to make this a lot easier to edit. Also, I can already feel myself speaking a lot more confidently without the all-knowing gaze of the camera upon me. So that's great. Onward. Some more background though. In case you don't know, this is Valentine. Valentine is a compressor and distortion effect. It's free. It's open source. You should go check it out I'll put the links in the show description. Anyway, so this is a compression and distortion effect, and it's meant to do really aggressive compression that brings new dynamic movement into the audio. So you kind of heard an example before, but here's something a little more dramatic. So here's this. So that's without the effect enabled. Now let's enable the effect. So you can see immediately when the effect came on, a lot of the reverb and room tone from the drum kit came out. And I really like doing that kind of thing to drums and other sources, of course, but I test it mainly on drums. Given that Valentine is meant to create really dramatic compression effects like this, it makes a lot of sense to introduce a new feature, sidechain compression. Actually, another bit of housekeeping as well. I'm going to proceed assuming that you're familiar with how compressors work. If you aren't and would like me to do a video about this, let me know in the comments. Okay, so what is sidechain compression at least? Sidechain compression refers to a compression technique where the source of the compressor's sidechain signal is different than the signal being affected. Right, so let's compare and contrast these two examples. Here's the sample again, this deep house. So you can hear that when the kick When the kick hits, let's make it really obvious. When the kick hits, that's when the compression really, well, it's hard to see with the meter. Maybe I'll compress it a little bit less. So if you look at the meter here, and also if you use your ears, you can hear that compression is happening during the loudest parts of this signal here, right? The kick, I guess kick, 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 kick. Oh yeah, it's not a kick snare, kick snare. This, whatever this actually is, let's call it right, that's a conventional compression. The signal that is being affected is the same signal that's used to figure out how to do the compression. In contrast, Sidechain uses a different signal to figure out when to compress. So let's turn off the compression on this little loop here and stop playing that deep house sample. Right, so first off, there's not really any place, right? This doesn't really have any dynamics, right? If I were to actually set a compressor and have it look at this signal, it would either compress not at all or pretty much compress all the time, because it's just about doing the same thing all the time. However, this is not using the signal that's being affected to figure out the compression. It's using this kick. Let's play the kick. And actually, to make the point even more strongly, let's see what happens. Yeah, okay. Oh, okay. Wow. So let's turn that gain way down. But you can see now that what used to be just one piece of sound just cruising along, I'm going to turn that kick off. That's doing its thing. Now it's got the rhythm of the kick imposed on it. Cool. Adding sidechain compression to Valentine would give users different ways to make their tracks move in interesting ways. Since we're using the Juice framework, this is actually pretty straightforward. Not so straightforward that I don't think it makes sense to talk about how we can split this work up to make it easy to manage and easy to troubleshoot in case anything goes wrong. So we're going to do this in two parts. One, we're going to get sidechain signal from the host, from live into my plugin. And two, we're going to use that sidechain signal in Valentine's compression algorithm. And we're going to validate each of these steps before moving forward in a few ways. One, in terms of getting the sidechain signal from the host, we can do a few things. One, take a look at how Valentine is displayed by the host's device UI. Here is a version of Valentine that does not have sidechain. As you can see, there's no sidechain because it hasn't declared one, or the availability of sidechain input. And here's a version that I implemented earlier that has it. Cool. That's step one. Step two, we can use the meters in Valentine. We're going to use the meters in Valentine to verify that we're actually getting signal from the host into the plugin. And then when we implement the actual use of the sidechain signal, we're going to listen. and see if it sounds like it's got some sidechain stuff going on. So let's dive in. So step one, how do we get sidechain input into Valentine? This is actually pretty straightforward. We just need to add additional inputs to the plugin. Oh. We can do this using the bus properties object that's given to the plugin processor when we construct it. Let's look at the constructor for the Valentine audio processor. Valentine processor. Interesting. What is it called? You'll have to excuse the organization here. This is some of the first C++ I wrote. Anyway, Valentine audio processor. This is the constructor for Valentine's audio processor. So as you can see, the first thing that we do is we initialize the base class audio processor with this bus's properties object. And you can create a bus's properties object and then configure it with input and with output. So let's take a look at bus's properties. Structure used for audio processor callbacks. We've got some input layouts, got some output layouts. We've got add bus. Okay. So let's see what happens. I paused for a second because I thought, do I want to, I don't want to do that. Do I want to go in here and really look at the implementation, see what's going on? And I realized, no, I don't. We're just going to explore and see what happens. Keep things moving. Anyway, so, and also that's not even the function we're using. We're using with input. That's interesting. Actually, now I am interested. Bus's properties. How does this work? Bus's properties with input. So it just, I don't know what I was expecting. It just adds an input. Cool. Seems straightforward enough. So with input, sidechain, juice, audio, channel set, stereo. True. Let's see if this builds. It's taking its time. That's very interesting. Oh, that's because I am building a release build. Let's cancel that. And let's build debug. There we go. Okay, great. We've built that. But here's another thing I want to do before we check that out. Because you may have noticed that I had multiple versions of Valentine up and running, and it might get confusing if there are a bunch of different Valentine versions on my system. So we're going to do something real quick. First, we're going to add this. So one thing that one of the Bacon Paul, one of the Surge XT maintainers who's been insanely helpful in helping me set up Valentine as an open source project. One of the things he recommended that I do is that I use commit hashes as a build ID. So that's what we're going to do. Just a little side note in order to make sure that we're looking at the plugin that we think we're looking at. We have sidechain. Let's make sure that it is... no. That is not the correct Valentine. Let's actually build it again. Missed that part. The way that it works is whenever it builds, it takes the current commit hash and uses that to make the build ID. So, of course, if I make a commit, I need to hit build again. Which, now that I think of it, well, whatever. Okay, so live's up. And let's see if we've got the correct... No, we do not. I think I've got it sorted out. Let's open this. FCAC 9FD. Is that what we're looking for? That is what we're looking for. All right, we are now in business. Okay. So now that we know we're actually looking at the correct plugin, let's do our first validation. Well, one, I will actually, because I've been waving this around, I'm still figuring all this stuff out. I realize that's real small, so I'm going to... Yes, that's a lot bigger, just for demonstration purposes. And as you can see, Live's device UI for the plugin recognizes that it accepts sidechain input and makes the widget that we want for it. Cool. Now let's see what happens when we try to do something with it. That's a little trick. I was not expecting that to work. We, of course, haven't changed any of the other code that handles this, handles the input. So let's start the process of doing that. Okay. So we changed the number of inputs accepted by Valentine. And that's going to change the size of the buffer that we get. And it's going to change some of the assumptions that we used to be able to make about the processor, or about that buffer, and then how they're used in the processor. So let's take a look at total number of input channels. Returns the total number of input channels. This method will return the total number of input channels by accumulating the number of channels on each input bus. The number of channels of the buffer passed your process block callback will be equivalent to either get total num input channels or get total num output channels, whichever is greater. Note, here's an important note, that get total num input channels is equivalent to get main bus num input channels if your processor does not have any side chains or aux buses. So there's this get main bus num input channels. What are you? Returns the number of input channels on the main bus. What was I expecting? I don't know. Okay, I think actually, let's take a look at how we were using. So this is the boilerplate code that they put in here. Originally, when I implemented the plugin, I wasn't thinking about sidechain or anything like that. So I didn't have to have a concept in my mind of what's a main bus and what's another bus, sidechain bus. So this worked completely fine. Anyway, so how do we use total num input channels? So first of all, right, when it comes to just taking normal audio input and no sidechain, that's going to be the same as total num output channels, because that's the same bus, right? We get a buffer, we read samples off of it, but then we write back into it. What do we use it for? I used that to figure out what our process buffer, how many channels it should have. The process buffer is, since we have a dry wet mix control, it is the buffer width process signal. It's also the one that gets upsampled and all that fun stuff to it. So we have to set the size to the total number of output channels. And then we iterate over the total number of input channels. And we copy from the buffer given to us by the host into our process buffer. And then we do some other preparation. What do we do here? Prepares the input buffer for processing, accounting for possible changes to the number of... yes. This is meant to handle cases where the buffer received in process block is in fact different from what was reported by the host in prepare to play. Anyway, so there's a lot of places where we would obviously crash. One is here, because total num input channels when we engage the sidechain is going to be 4. Process buffer is going to have 2 channels. So at some point, we're going to be touching memory that we should not be. Let's demonstrate. Let's see where exactly we try to do this copy. Channel is 2, but process buffer is only ever going to have 2 channels in it. So there are a few things we need to do in order to make this not crash and also make this a little bit easier to understand. So let's do them both at the same time. Why not? So first, what we want to do is num main bus get total num get num. I forgot what the name of the get main bus num input channels. All right. Now we have num main bus channels, and we're going to want to use that to wherever we refer to total num input channels, right? Process buffer, we set size to the num main bus channels. Commit. Correctly handle main input buffer sizes. Main input channel counts. Cool. Actually, let's build it one more time. Let's also keep an eye out just to make sure that we've got, or I guess we could also just check to see whether the behavior persists. We could do that as well. But I am feeling a little bit paranoid because of the issues I had earlier. Let's see. You have sidechain. What are you? No, you're the wrong build. You know, I am glad in this case because, okay, full disclosure, I have been messing with my build system because I wanted to build release and realized after some changing computers and missing configurations that I forgot how to do this. And it looks like I haven't really got it completely right. That is the commit ID we're looking for. Wow, that saved my bacon. Because you better believe that there would have been a lot of like, wait, why is this still crashing? And of course, you know, I think what would have happened is that it still would, you know, even though the binary is not the one I expect, it would still go, the stack trace would still go to the same place, and I would be in a real bad headspace. Anyway, live is taking too long, so I'm going to Come on. There we go. Okay. So let's open live up. B026EE. Is this our get show? Yes, fantastic. Okay, so can we? Okay, great. We can get sidechain in. I'm gonna zoom in for you again. We can get sidechain in. We can select sidechain, and nothing catastrophic happens. Cool. Of course, nothing is going to happen because it's not hooked into anything. So we'll move to the next step of our validation, which is not the compressor. It is, let's just throw this into the meter. There's two things that we need to do. First of all, how do the meters work? Loosely, there is this object called input meter source. It, I think, measures the RMS, measures the buffer in order to then send that information over to the GUI so it can to the GUI thread so it can paint those lovely meters. Foley's finest, by the way, which is a great open source and free option. It's a juice module. So currently this just measures the buffer. And actually, because of something interesting is going to happen here. What if early boards of Canada was pretty bad? Okay, so we have Valentine across this pad. And let's just... We can see that when we set the sidechain, the meters actually turn into 4 meters. Why? Here we go. Input meter source. Resize. Get total number of input channels. It would be better to just do get main bus num input channels. Let's see. Okay, cool. Yep. As you can see, we're still getting the main input in those meters. Let's mess with those meters a little bit in order to verify we're actually getting the signal in, or that at least that we know how to handle it, right? So how do we get there is a function called get bus. Yeah, get bus buffer. How do you actually use that? Oops. Where are you? Get bus buffer. Returns an audio buffer containing a set of channel pointers for a specific bus. Okay, cool. So get bus buffer. You give it the buffer, and it gives you another one. Pool is input. Bus index. Okay, so sidechain buffer equals get buffer is input. I think that's false, and we're doing bus index. And let's put a sidechain buffer in there. Oh. You're mad at me. I think actually this should be true because it is the sidechain buffer is an input buffer. Wow, still striking out. What's going on here? This is just kind of a main input output buffer equals get bus buffer true 0. Can we get one from the main channel? Let's just open this up and see what happens. Okay. Interesting. Well, why that was not working before, I don't know. So we've already figured out that we do get the sidechain in there. Let's just set it back to how it was. Okay, so we've set this back to its normal state where the meter is going to show the input of the main signal, not the sidechain signal. Now for the final piece, actually using the sidechain signal that we have gotten into the process block function. In order to do that, we're going to have to change how the compressor in Valentine works. As you can see here, it has this process function and it's taking this DSP audio block object and it takes that input audio and copies it into this pre-allocated sidechain buffer. So things are a little bit different now. We need a way to get sidechain signal into this function. So let's just declare it as such. We're going to, along with in audio, we're going to accept a reference to some sidechain audio. And I've gone to the wrong thing again. Here we go. And we're going to simply, and luckily for me, that's about all there is to it. That's about all there is to it. Because of course, we still have to call it correctly. And we've changed the interface. So here we have the original way we called it. So you might be wondering, well, how do you call this if you don't have a sidechain? Well, remember, that's the weird thing about the naming of sidechain compression, right? There is always a sidechain. What we call sidechain compression, as I was saying in the introduction, is that the sidechain source is different. This is our conventional case. No external sidechain. So we simply give it a reference to the same input audio as the sidechain signal. Cool. And we should check to make sure nothing's broken. And actually, let's be precious. And yep. Adapt compressor to take independent sidechain input. Let's build it again so we get the commit hash And let's see now if we're looking at the correct Valentine. 3648. Okay, thank goodness. Right, so if we open... It still works as intended. Great. Let's do the next step. And that is change the sidechain depending on whether or not we have external sidechain input or not. And we're actually have to do a few things, but let's do the basic vibe here. If sidechain buffer dot getnum channels is greater than 0, we are going to compressor process high sample rate block, and then what exactly? We can put this in as a placeholder, but so you can see this takes audio block, and also if you'll notice in these two cases, these are both upsampled audio. So we actually need to upsample the sidechain as well. Let's add another upsampler, oversampler, upsampler, whatever. Okay. You'll notice that I will declare it differently. And that's simply because I think it's more clear to do it this way. There's no good reason to hold these as pointers for my application. So maybe one day I'll change all of this over. For now, I'm gonna leave it like this. But we still need to make sure that we correctly initialize it. So we've declared the sidechain oversampler. Great. What else have we got going on here? So let's do a little more. Let's do some copy pasting, a little more copy pasting. So we got. Oh, and actually, I recently learned that I don't need to do that. I could just do, as you can see, I create an audio block here and then I pass that audio block in. I can just sampled a side chain. Don't need that intermediate variable. So we will create an audio block with an upsampled sidechain signal using the sidechain oversampler. And it is not a pointer anymore. Okay, so if we have sidechain, else we will just process it using the main input as the sidechain. So let's add all that. Comment. Use sidechain signal if use sidechain signal for use external sidechain signal for processing if present. Cool. I'm going to Let's launch live and take a listen. Does not seem to be working. Why is that? I was missing something insanely important. I didn't correctly initialize the oversampler. Hey, look at that. So we're just missing one piece. So if you'll notice, currently the compress parameter isn't actually doing anything to the amount of compression that happens. This is because of a design decision in Valentine. A lot of compressors, maybe even most compressors, especially digital compressors, generally work by letting you adjust the threshold at which gain reduction happens, right? So actually I'll open live back up for that. So if we look at the Ableton compressor, and for the purposes of this example, make it super goofy and big, right? You want more compression, you turn down this threshold. Some compressors, Valentine included, don't do it this way. Valentine has a more or less fixed threshold, and the way that you actually affect the amount of compression that you want to have is you increase the amount of gain going into the compression. So that's what this is right here. The compress knob is actually a gain knob. So in order to make this work in a way that makes sense for sidechain compression, we're going to have to do something a little bit different with applying the gain. And of course, we're doing another get num channels. If it's greater than 0, right? And we're going to apply that gain ramp to the sidechain buffer instead of the main buffer. Or in this case, the process buffer, because the process buffer is corresponds to the main buffer in this case. And let's see what we have. There it is. Let's review what we did. So the first thing was added a new input to the bus's properties object that's given to the base class of our audio processor when it's instantiated. We adapted some code that depends on the number of input channels in order to account for the new reality that our input buffer in the process block might have 2 or 4 channels. We adapted Valentine to take advantage of the independent sidechain signal that it might be getting. After that, we actually used the external sidechain signal. And in order to do that, we had to add a new oversampler. We had to correctly set it up and initialize it. And then we had to upsample the sidechain signal before using it for processing. And finally, we made it so Valentine's compression parameter actually affects the amount of compression that you get if we're using an external sidechain input. Great, well, we've got some basic sidechain compression going on. Awesome. Of course, this is nowhere near mergeable yet. Need to do some refactoring, need to do a lot of testing, and probably a lot of finding out that things crash on some other host. Who knows? It'll be an interesting adventure. But for now, I'm happy. And now that we've redesigned the compressor to take a different sidechain, we've actually opened the door to maybe new features, right? We have external sidechain now. Maybe in the future, I can work on something like sidechain EQ. If that's something you would like to see me do, please let me know in the comments. And yeah, please try Valentine, contribute to Valentine. Let me know what you think about it. It would be really helpful to see what people want to do with it. Anyway, as always, thank you for joining, and I'll see you next time.